Hey folks, welcome back. We're going to try to finish up 2.7 here. All right, so the graph of the equation of x squared plus y squared equals 4 is a circle centered at the origin with a radius of 2. We might remember that from our parabola or our conic sections lesson and geometry or maybe algebra 2 or maybe pre-calculus. Anyway, all right, so the x squared plus y squared equals 4 is a circle centered at the origin with a radius of 2. Kind of makes sense, right? If I change this to a 16, this would become a radius of 4. If I change this to a 49, this would become a radius of 2. Anyway, sketch the graph of the equation. So let's start off fairly easy. We're going to make a sketch. If I have a radius of 2, I only need to go 2 in each direction. 1, 2, 1, 2, 1, 2, 1, 2. Then we're supposed to make a circle out of this. All right, here's, oh boy, I did not do a very good job on my distances. Yeah, close enough. All right, sketch a graph. All right, now find dy dx. All right, so we have this equation. First of all, could we get y by itself? You could, but you'd have to square root, which means you'd have to do plus or minus, which would kind of cause some issues here. I don't want to do the derivative twice, so I'm just going to go ahead and derive this implicitly. So let's do it. ddx of x squared plus y squared equals ddx of 4. The derivative of x according to x is 2x. The derivative of y squared, let me try again. The derivative of x squared according to x is 2x. The derivative of y squared according to x is 2y, y prime. The derivative of 4 is 0. Remember what your goal is here. You want to get all your dy dx stuff on the same side, and you want to get your non-y prime stuff to the other side. So I get 2y times y prime equals negative 2x. Then I'm going to divide both sides. I got a sneeze coming. Here it goes. Now I'm going to divide off that 2y. So I get y prime equals negative 2x over 2y. And what's going to happen to those 2's? Those are going to divide off. And so we get y prime, or actually I'm going to write it as dy dx this time. Dy dx is negative x over y. I'm going to go back and change all of those for next year. I think I want to use it dy dx next year. Ugh, that looks horrible. Why didn't I just leave it? Dy dx y prime. I ended up putting y prime back in there. Oh, how annoying. Okay, all right, live with it, stuck. You're all right, it's all right. Okay, so using calculus, verify that the graph has horizontal tangents at the points 0, 2, and 0, negative 2. That kind of makes sense. If I look up here, 0, 2, and 0, negative 2, I would guess if I were to draw the tangent lines there, that I would have horizontal tangent lines. It seems intuitively, as I look at it, I'm guessing that that's true. But now I have to verify that this is true. All right, so remember, horizontal tangent lines. This is worth memorizing. You've got to remember this. Otherwise, you're dead in the water. You've got to remember this chart. So horizontal tangent lines are the ones that have a slope of 0, which means there's a 0 on the top, not a 0 on the bottom. Then we're going to do vertical tangent lines, which means a 0 on the bottom, VAs. And then the whole is that one doesn't show up very often. So the reminder here is that dy dx needs to be equal to something that is equal to 0 on the top and not equal to 0 on the bottom. So I'm going to take my dy dx equation And I'm going to say, all right, so let's set that up. So we would have dy dx equals negative x over y. And we want this to equal 0. And we want this to equal not 0. Okay, so this is basically telling us that y can't be 0. And it's telling us then that this implies then that x is equal to 0. So if what we're going to do now is we're going to now figure out what the y value is associated with this x value. Okay, let me kind of start over here. The graph has horizontal tangent lines wherever the top equals 0 of my derivative and the bottom doesn't equal 0. So I did that. I set this up. So I know that y is equal to 0 and, sorry, let me try again. X is equal to 0 and y cannot be equal to 0. So if we find out at the end here, when I plug in 0 to get my y values, if I plug in 0 and I get a y value of 0, that doesn't count. So y can't be 0 either. How do we find points? So now I'm going to go find some points. Find y values. If I want to find my y values, I've got to plug this x equals 0. I know x has to be 0. I know that y can't be 0. So we're going to worry about that later. So if x equals 0, I'm going to go back to my point machine and I'm going to put x equals 0 in there. So I would have 0 squared plus y squared equals 4. Well, that 0 doesn't matter, so I would have y squared equals 4. I would square root both sides, and I would get y squared equals plus or minus 2. My bad. I would get y equals, oh man, I'm still struggling from this error up here. I would get y equals plus or minus 2. So what did we just verify? We verified that when x equals 0 and y equals plus or minus 2, we have a horizontal tangent line. Check. So our horizontal tangent line lines occur at 0 plus or minus 2. Now you got to be a little bit careful when you do that 0 plus or minus 2, but that's okay because that one x of 0 ended up with a y value of plus or minus 2. I'll show you. I think there's an example later in the notes that I'm talking about here. Well, let me just do a little side note. I'll do a little side example here to show you what I'm talking about. You got to be careful about this plus or minus stuff. Let's say x equals 2 and y equals negative 3. And at the same time, x equals negative 2 and y equals positive 3. Well, it's kind of tempting to write this up as plus or minus 2, comma, plus or minus 3. The problem with that is that this has 4 points in it. This has 4 points. This has the point 2 goes with 3, 2 goes with negative 3. Negative 2 goes with 3, negative 2 goes with negative 3, which is different than this. This has 2 points. So you got to be clear. Just make sure that you're saying what you mean to say. All right, so using calculus, verify that the graph has vertical tangent lines at 2, 0 and negative 2, 0. As we look at the picture, that seems reasonable. At negative 2, if I drew a tangent line, it does look like it's vertical. It does look like it's vertical. So I'm going to encourage you to try to do this one on your own. Pause if you haven't paused yet. Okay, my vertical tangent lines. I have a horizontal tangent lines when I get 0. And I get a vertical tangent lines when I get undefined. If I want to get undefined, that means I have to have not 0 on the top and yes 0 on the bottom. So I'm going to go back to my derivative, which is dy dx. which is equal to negative x over y. And then I want to make sure that negative x doesn't equal 0 and y does equal 0. So this implies two things. The big thing, the more important thing, is that y equals 0. That's what we know. But at the same time, and we know that x cannot be 0. So if we end up getting an x value that is 0, we have to disregard that point, because otherwise it would give us a 0 over 0 scenario. All right, so let's do what we did before. Let's now find those values. Find our x values. We find our x values by using the point machine. That's this guy. We know what our y values are this time. We don't know what our x values are. So we go x squared plus, this time our y value is 0, squared equals 4, which really means x squared equals 4, which really means x equals plus or minus 2. So our graph has vertical tangent lines at plus or minus 2, comma 0. That's okay because there are 2 points here, and those are the 2 points that we find over here. All right, so at what values of x is the slope 3/4? So the idea of this here is to show you that this whole example is to show you that if you want to figure out where the slope is at a certain value, you take the derivative and you set it up equal to that slope. Now you got to remember, what does a horizontal slope look like? Horizontal lines have a slope of 0. They go horizontally. There's no change from left to right. Vertical lines have undefined slope, which is a vertical asymptote, which means you got to have a 0 on the bottom. If you want your slope to be 3/4, I would just take my slope and set it equal to 3/4. So here, if I want the slope to be 3/4, then I would take dy dx, and I would set it equal to 3/4. Well, let's do that. So, what would be a good color? We haven't used red. Oh, yeah, we did red at the beginning. How about a nice orange? We haven't done anything in orange yet. So, dy dx equals negative x over y. And we want that to equal 3 over 4. Now, what I thought when I first did this was this meant that x was negative 3 and y was positive 4. No, that's a relationship between these two variables. That's not all the possible combinations. So what we want to do now is we want to solve this for one of our variables, and it really doesn't matter which one. So what I'm going to do is I'm going to take this, I'm going to do a little cross multiplying. So I would get negative 4x equals 3y. Then I would try to pick a variable to get by himself. Since x is already on the left side, I'm going to choose to get x by himself. So I'm going to divide both sides by negative 4, and I get x equals negative 3/4 y. All right, so now we know that all the values, when x is negative 3/4 of whatever y is, you're going to have a slope of 3/4. Now we have to go figure out where those actual points are. So I'm going to take this and I'm going to now find some points. I'm going to find my y values. So what would that look like? I go back, if I want to find points, I'm going to use my point machine, which is the equation. So x squared, well, that would become negative 3/4 y squared plus y squared equals 4. I'm going to square the top and the bottom, so that would be 9/16 y squared plus, I'm going to get a little proactive here. I'm going to change this into 16/16 y squared equals 4. Because now I can add those together. 9 plus 16 is 25. I like the look of that with all these squares. I like seeing perfect squares along the way. Okay, now I'm going to get rid of this. Now there's two ways to do this. You can divide by 25/16, but then you're going to have a fraction on the bottom, which means you're going to have to flip and multiply anyway. So instead of that, what I'm going to do is I'm going to multiply right away by the reciprocal. So I'm going to times this by 16/25. I'm going to flip and multiply right off the bat. 16/25. So that would leave me with y squared equals 4 times 16 is 64/25. Therefore, y is equal to plus or minus 8/5. So life is good. I've got some y values. Problem is I also need some x values. Now there's a couple of ways for you to do this. You could then take this and plug it back in, blah, 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 and do this all over again. Or you can use this equation to help you figure out what the relationship between those two things are, and that's what I'm going to do. So what would be a good color to end with here? How about brown? Find x values. So I'm going to now take my x equals -3/4 times my y value is plus or minus 8/5, and I can handle this at the same time. That's okay. Now, what's that negative going to do to this plus or minus? Well, it's just going to make it minus plus, which is still plus or minus. So x equals, this would be plus or minus, what would it be? Well, let's reduce it. Actually, I can, well, I'll clean it up. I'll show my work. 24/20, which then reduces, what, 4 goes into both of those, 6/5. I wish I wouldn't have boxed that in. So now I would write then that at what values of x is the slope of the graph 3/4? My values would be, let's go back to orange since that's where we started. It would be plus or minus 6/5 with plus or minus 8/5. No, no. I just fell for my own trap. No, 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 no. I want to plug these in separately. No, 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 no. Sorry guys, I hate it when I do this too. No, I need to plug these in separately. When x is 8/5, let me try this again. I'm going to cross this whole section out. Now let's try this again. Trying to get a color that won't kind of mix with those two. I'll go with pink, I guess. Find x values if y equals 8/5, then x equals -3/4 times 8/5, which equals, that cancels, that would be -6/5. This is important. Yes, this is better. If y equals -8/5, then x equals -3/4 times -8/5, which equals positive 6/5. So where are the two places? So my actual answers would be negative 6/5 matches up with 8/5, and 6/5 matches up with negative 8/5. Now let me talk about why I knew that the other answer wasn't right. Because then I thought about it, and I was glad that Corpy had us graph this thing. Where are the places where the graph would have a slope of 3/4? Well, the slope of 3/4 would be some sort of positive slope. So like here in example 7b, horizontal tangent line. Yeah, I buy that. There's the horizontal tangent line. It's good. If I go down to this one, if I look at 7c, where are my vertical tangent lines? My vertical tangent lines are supposed to occur at 2 and negative. Yeah, I buy that. Right there and right there. Those have vertical tangent lines. I buy that. But if I have a slope of 3/4, that's some sort of positive slope. So I'm going to pretend, I know it's not right, but I'm just going to pretend that my slopes, here's one of them, here's the other one. I know that's probably not perfectly there, but somewhere in there, those slopes are 3/4. The reason I knew it wasn't all four answers was because these have I could have a slope of 3/4 here, but it would be negative. I could have a slope of 3/4 here, but it would be negative. So I knew that once I looked back at the picture and I double checked my thinking, it made sense that there'd only be two answers, where if I wrote it like this, there would actually be four answers. So you do have to be careful of those little tricks of the trade. Always think back and say, does this seem reasonable based on the picture? Okay, so thankfully in the next example, Corpy drew it for us. So he used some sort of program to sketch this rotated ellipse based on this equation. Determine the x values of any horizontal tangent lines to the graph, blah, blah, blah. I'm going to encourage you to pause here and try to do this on your own. And then, as always, you can check in as you're going through. So horizontal tangent lines. Okay, horizontal tangent lines means y prime equals 0, which means slope equals 0. But for us, we know that this is going to end up as a dy dx scenario. So dy dx needs to equal, okay, I want horizontal, which means I want the answer to be 0, which means I needed there to be a 0 on the top divided by a not 0 on the bottom. Because if it was a 0 on the top and a 0 on the bottom, we'd be in trouble. Okay, so that's the scenario that I want to generate. Now I have to go figure out what my derivative is. This time I am going to use dy dx, so I don't have to go back and be frustrated by my notes. D dx of 2x squared plus xy plus 4y squared equals d dx of 3. I like that. All right, so let's start deriving this. Derivative of 2x squared according to x is 4x. The derivative of xy, okay, that's a product rule. So this is my u and this is my v. This is u and this is v. So the product rule is u prime, which is 1, times v, which is y, plus u, which is x, times v prime, which is y prime, plus 4y squared would be 8y, but I need a y prime. Derivative of a constant is 0. All right, so now I'm going to move all of my non-y prime stuff to the other side. So I would have, what, x times y prime plus 8y times y prime equals negative 4x and a minus y. So then, dang it, I said I was going to do dy dx, and I still forgot. So dy dx is equal to negative 4x minus y over x plus 8y. Okay, so all that allowed me to do, this is now my slope machine. This finds all my slopes. If I want to have a horizontal tangent line, that means that the top of this has to equal 0 and the bottom of this has to not equal 0. So I'm just going to focus on the first one, or on the top part, and then we'll see if the bottom part comes into play. So we would get negative 4x minus y equals 0. I'm going to move the 4 and then divide. I guess I would get, either way, I get y equals negative, either way we would get y equals negative 4x. Okay, so if y equals negative 4x, what I can do now is I want to find the x values that are associated with that. So what I'm going to do is I'm going to take this, I'm going to plug it back into my point machine, which is my equation. So that would look like 2x squared plus x times negative 4x plus 4 times negative 4x squared equals 3. What's nice about this is I now have an equation that only has x's in it. That means that I can solve it. So I get 2x squared minus 4x squared. That would be 16 times 4, so that's plus 64. X squared equals 3. I've got a bunch of squared stuff, so I can put that all together. 64 take away 4 is 60, plus 2 is 62. 62x squared equals 3. And I would divide by 62, and I would square root, so I would get x equals plus or minus square root of 3 over 62. Now, what do I want to do with this? This says determine the x values. Oh, life is good here. Determine the x values. These are the x values. Now, just to be clear, if I plug this in here for x, I move it to the other side, and I divide by 8, I would get some number that's not equal to 0. That's a good thing. That's a good thing, because we know that this, you're not supposed to get a 0 on the top and a 0 on the bottom here. All right, let's have you try the next one. Pause it, see how far you can get. Okay, so this time we want to find vertical tangent lines. This means that my slope equals undefined, dot, 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 which means dy dx equals not 0 on the top and 0 on the bottom. So if I want dy dx, if I want my line to be vertical, that means I have to divide by 0, the worst thing in all of mathematics. All right, so let's do, we've already done our derivative, so we can cut to the chase there. We already know that dy dx is equal to negative 4x minus 4, negative 4x minus y over x plus 8y. This time, I want this to not equal 0, which I'll think about. I'm not going to usually use that to solve, and I want this to equal 0. So we can use that now to we would get 8x plus 8y equals 0. This time I'm going to solve for x. So x equals negative 8y. All right, now we're supposed to find the y values using this relationship. So that means it's a point machine. I'm going to take this, I'm going to plug it back into the point machine, which is our function. So we would say something along the lines of 2 times the quantity of negative 8y squared plus negative 8y times y plus 4y squared equals 3. Now we can start to clean this up. That's 64 times 2 is 128. 128y squared minus 8 times y is y squared plus 4y squared equals 3. 128 minus 8 is 120 plus 4 is 124. Y squared equals 3. Divide by square root, that means y equals plus or minus the square root of 3 over 124. If you want to be fancy, I know 3 goes into 124, so you could clean it up a little bit, but they only want the y values. I don't want to clean that up. I don't think it makes life any easier. Let's clean it up. Let's just see what it, I just am curious now. It'd be 1 over 3 goes into there, 4, 5, 6. No, it doesn't reduce. Sorry. I thought it did. Okay, now let's double check this. Let's see if this makes sense. Where on this picture would you draw the horizontal tangent lines? I would say there's one kind of up there, maybe down there. There's my horizontal tangent lines. I didn't do a very good job of hitting an actual point there. But let's see where what this number is and see if that's close to our picture. So let's see, what is the number square root of 3 divided by 62? So at plus or minus 0.2. 0.2 would be about there. Boom. Negative 0.2 would be about there. Boom. Yeah, we did pretty good. My line here was not very well drawn, but it seems reasonable. Let's see if that's the same thing here. Vertical tangent lines. Where would you draw vertical tangent lines? I would say one is probably like right here. Let's say one is probably like right here. Let's see how close. This looks like 1.2, 1.25 maybe, 1.25. Let's see, what's the, now I'm going to type in this one. What's the square root of 3 divided by 124? 0.1. Oh. Wait a minute. That's not, oh, dang it, it's the y values. It's the y value. Oh, I was freaking out. This is the y value. So does that look like a y value of negative 0.2 somewhere pretty close? Yeah, pretty close. I'm going to leave myself a note for this next year. Y values. Okay, let's finish up here. Determine the equation of the tangent line, blah, 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 at blah, blah, blah. Okay, man, this is easy. Go for it. You got it. It's not simple, but it's straightforward. Okay, so this is, look, we just keep applying the same concepts over and over again in different ways. The equation of the tangent line, well, what do we need? We want the equation of the tangent line. Well, we need a point. Do we have a point? Yeah, our point is 3, 1, so I don't even need to write c, f of c this time. Do we have the slope? Yeah, the slope is equal to the derivative. So for us, that's dy dx or y prime. So now we got to go figure out what's y prime at that spot. All right, let's figure out that derivative then. So I'm going to take d dx of 3 times the quantity x squared plus y squared is equal to d dx of 100 xy. Oh boy, this isn't so easy. This is pretty nasty. So this is what? This is what type of rule? This is a chain. I've got something inside the chain with a sum, but I don't like to write the sum. This is 100x times y, so this is a product rule. I'm going to encourage you to pause here and see how far you can get on your own. Okay, so chain rule. 3 something squared. The derivative of 3 something squared is 6 something to the first times, now I got to do the derivative of the something. This is a sum rule, so the derivative of x squared is 2x, plus the derivative of y squared is 2y, y prime. Equals, okay, this is a product rule. 100x is my u, y is my v. So u prime would be 100 times v plus u, which is 100x, times v prime. So this is a perfect scenario of where you do not want to try to get y prime by itself. You would distribute this, you'd move stuff and rearrange. But this is a scenario where I would recommend plugging in the 0.31 and saving yourself some headaches. So I'm going to now plug in the 0.31. So we've got 6 times 3 squared. Now I'm doing this for my notes, so I'm showing out every single step. If you want to, as you're plugging things in, like if you want to do 3 squared and write 9, I'm totally fine with that. Hey boy, let's try to clean some of this up. So this is going to end up being, so this is 9 plus 1 is 10, and 10 times 6 is 60. At least I can put that much together. I don't want to go orange, I want to go green. 60 times, okay, this would be 2 times 3 is 6, plus 2 times 1 times y prime is 2y prime, equals 100 times 1 is 100, plus 300 y prime. I guess I would distribute now. So 60 times 6 is 360. 60 times 2 is 120. And now I want to get the y prime stuff to one side, and I want to get the non-y prime stuff to the other side. So I'm going to do a double move. I'm going to subtract 120, and I'm going to subtract 100. So subtract 100, that's easy. That's 260. 300 subtract 120, so that's 30 take away 12 basically, which is 180. Which means now I can divide by 180. I get y prime equals 260 over 180. Kill off the zeros. Then that's just 26 over 18. Let's divide that by 2. So that would be 13 over 9. Okay, now that's important. What is that? What did we just find? This is our slope at 3, 1. So now I can take this all together and make my equation. So my equation would be y equals y plus my slope times x minus 3. I think that's about as straight. I could very much see a problem like this on a test for me to, I guarantee it'll be on the AP test, but I think this would be very much what I would expect you to be able to do in this class. All right, let's finish up here. When asked to find a higher order derivative where implicit is needed, it's always beneficial to solve for dy dx prior to finding the second derivative. Okay, so what we're doing here is we're finding multiple derivatives. So you find the first derivative and then you derive again. It's always better when you're doing the derivatives to get y prime by itself. It's not good to do what I did here. It's more of a hassle that way. Okay, so let's take a look. So we want to find, this means the second derivative. So to find the second derivative, we first have to do the first derivative. So let's do the first derivative. So that would be d dx of 2x cubed minus 3y squared equals d dx of 8. So we derive this, that would be 6x squared minus 6y prime equals 0. Now I want to get y prime by himself, so I'm going to minus this over. I would get negative 6y prime equals 6x squared. Sorry, negative 6x squared. I'm going to save myself a step here. When I divide, I know those negative 6's are going to cancel, and I get y prime equals x squared over y. All right, now that's just the first derivative. We now want to find the second derivative. So we're going to derive again. Well, first of all, what type of rule is, let's derive again. Y prime equals x squared over y. What type of rule is this? This is a quotient rule. And I'm going to show my u's and v's on this one just to be, no I'm not. No I'm not. All right, ready? So let me get a different color. Do your u's and v's while you're waiting for me. All right, let's see here. So now I'm doing the derivative of y again. So that would be d dx of y prime, d dx of x squared over y. Derivative of this would be y double prime or y prime prime. That's my u, that's my v. Okay, so it's u prime, so that would be 2x, u prime v, minus this time, u v prime, which is y prime, over v squared, which would be y squared. Okay, so this is what he's talking about up above, that you got to be careful here. So if I feel like I'm done, right? That's my answer. No. You always want to put back in things that you know. And we know, like the first derivative, y double prime can't still have derivatives in there. But we know what the derivative of this is. We know that y prime is equal to x squared over y. So what I'm going to do is I'm going to take out that y prime piece and I'm going to put that in its place. So I would have 2xy minus x squared times x squared over y over y squared. And now I can start to clean this up. So I would have 2xy minus x to the fourth over y over y squared. We know that nobody can... actually, let's get common denoms first. Let's get this together. Usually we would flip and multiply, but then I'd have to distribute. I guess that wouldn't be too bad. I'm going to get a common denom first. So that means that this guy needs a... what color could I use? Maybe gray. This guy needs a y on the bottom, which means I got to put an extra y there. So I would have 2xy squared minus x to the fourth over y all over y squared. Everybody knows that we can't divide a fraction by anything, so we make the other thing into a fraction and flip it over. So that becomes 1 over y squared. And we would get our second derivative to be 2xy squared minus x to the fourth all over y cubed. And that's what I'll box in. There's my second derivative. Woo! All right, so the big takeaway is you're pretty much just doing your derivatives like normal. You just got to remember, once you find the first derivative, you can then plug that in to find multiple derivatives after that. So, okay, so that's it for 2.7. Hopefully you've been doing some of the homework already. If not, you got some catching up to do. As always, you can ask me questions. We'll go from there. Good luck.